Modern homes are smarter, more energy efficient, and built with advanced materials. So why do so many of them become unbearably hot, even with air conditioning? Surprisingly, the answer isn't just the weather. It's hidden in the way many modern homes are designed. Today, we'll uncover the engineering decisions that can turn a beautiful home into a heat trap, and why older houses often stayed cooler without relying on technology. Welcome back to Next Gen Home Builders. If you look at the specifications of a newly constructed house today, it looks superior on paper in every single category. We are using precision-engineered wall systems, high-performance thermal insulation, and advanced multi-pane windows that are heavily marketed to protect your indoor environment. Yet, millions of homeowners moving into these new properties notice a frustrating and uncomfortable trend. During warm months, the interiors become stiflingly hot, turning into literal greenhouses. At first glance, this seems like the obvious reason. We assume it's just rising global temperatures or temporary summer heat waves, but it isn't the whole story. Older, traditional houses built decades ago with simpler materials often manage to stay remarkably comfortable in hot weather without running massive air conditioning units. How did newer homes become less comfortable in hot weather? To solve this, we have to look at how modern design choices trap energy. This brings us to our first major design shift: the obsession with massive glass. Modern architecture heavily prioritizes appearance, clean lines, and panoramic views over structural solar control. We now routinely install floor-to-ceiling glass panels and giant sun-facing windows along the western and southern elevations of a home. This creates a massive engineering vulnerability known as solar heat gain. Shortwave radiation from the sun passes straight through the clear glass effortlessly. Once inside, that light hits your floors, furniture, and walls, transforming into long-wave infrared radiation, which is pure heat. Because long-wave radiation cannot pass back out through modern energy-efficient glass coatings, the thermal energy is permanently trapped inside the room. At first glance, this seems like the obvious reason your home is baking, but it isn't the whole story. Glass plays a major role, but glass isn't the biggest reason modern homes overheat. The deeper issue is a hidden consequence of modern energy efficiency. Our homes became way too airtight. To meet strict building codes and prevent cold air drafts from escaping in the winter, modern construction relies on heavy house wraps, expanding foam sealants, and airtight vapor barriers. We have completely sealed the building envelope to the point where it can no longer breathe. The structural irony is that while stopping air leaks is excellent for keeping a house warm in the winter, it completely stops unwanted natural cooling in the summer. In an older home, tiny, natural structural gaps allowed stale, hot indoor air to continuously escape through the attic and walls while drawing cooler, fresh air inside. In a modern home, once heat gets inside through the windows, it has absolutely nowhere to go. The building seals the thermal energy in like a plastic thermos, forcing the property to become entirely dependent on constant mechanical ventilation and expensive air conditioning. Even perfectly sealed homes can stay cool if one important design feature isn't ignored. The real breakdown in modern residential development is that we completely forgot the laws of passive cooling. This is the strongest engineering lesson of all. Traditional builders didn't have heavy HVAC machinery, so they were forced to design buildings that worked with the local climate instead of fighting against it. They engineered deep roof overhangs and structural eaves that were precisely calculated to block the high, harsh summer sun while still letting the lower winter sun in. They aligned windows on opposite sides of the building envelope to facilitate natural cross-ventilation, utilizing pressure differences to pull a constant breeze through the living spaces. They integrated shaded central courtyards, high thermal mass brickwork that absorbed daytime heat and released it slowly at night, and they intentionally planted deciduous trees to provide natural summer shade. Many modern developers completely ignore the terrain. They clear-cut all vegetation, minimize roof eaves to save on framing costs, and face giant windows directly into the blazing sun, expecting brute force technology to fix the thermal errors. Furthermore, the physical properties of our construction materials have radically shifted over the years. Many modern homes are built using lightweight, rapid construction systems like thin-profile wood framing or lightweight steel studs rather than thick masonry. While these systems are fast and cost-effective, they possess very low thermal mass, meaning they cannot store heat energy safely. When the sun beats down on a lightweight wall or a dark, unventilated composite roof deck, the material temperature spikes instantly, radiating that heat directly into the drywall within a few hours. At first glance, this seems like the obvious reason to blame modern materials, but it isn't the whole story. Not all modern materials perform the same. A premium material used in a flawed design will always fail. Good engineering and structural orientation matter far more than simply using the newest, most expensive materials on the market. There's one final reason that surprises many homeowners. The ultimate payoff is this: modern homes are not inherently hotter or poorly built. The real problem is that poorly designed modern homes are. A high-performance modern house can completely outperform an older home if it is engineered with structural intelligence. The solution isn't to go backward and build drafty, uninsulated houses. The solution is to combine our advanced materials with proven passive principles. When you couple high-performance insulation and balanced mechanical ventilation with correct building orientation, strategic exterior shading fins, and the appropriate solar control glazing, you get a home that remains perfectly balanced, incredibly efficient, and naturally cool without forcing your cooling systems to redline. The lesson isn't that older homes were better or that modern architecture is flawed. It's that comfort depends on thoughtful design, not simply newer materials or larger windows. When a home works with its climate instead of against it, it can stay cooler, use less energy, and remain comfortable for years to come. In the end, good engineering will always outperform good looks alone. If you respect the uncompromised physics of building science, hit that like button to help us push this analysis through the algorithm. Don't forget to subscribe to the Next Gen Home Builders channel and turn on all notifications so you never miss our deep structural breakdowns. Let me know in the comments. Does your home trap heat? Thanks for watching, keep your tolerances tight, and I'll see you in the next analysis.